Hello and welcome everyone. It's so nice to have you with us today for our architectural community meetup. Today we are going to start our series about generative design. Now, a lot of you have attended the original sessions where we had Jacob Small and Emily Abisaga-Dunn meet with us and introduce a little bit of Dynamo. And everyone said, oh, that's very interesting to me. I would love to see more. And so Jacob was nice enough to come back to us and say, yes, I'd be willing to do this. And so I have Jacob Small and Sol Amor with me, who will be presenting. So they'll be doing a little back and forth. And I also have Naman Maisawala with us again. He is our expert elite who will be helping us with questions and answers in the background. So I'm very excited. It's going to be a great session. While we're still waiting for a few people to log in and get their audio started, I do want to find out who's with us. So if you will, go ahead and type in the Q&A panel where you are coming in from, and I will try to catch everyone. I know there's going to be so many of you today that I won't be able to introduce everyone, but I am excited to introduce as many as I can. So let me open that up. See that? There's already too many. I can't see them all. Okay, so Vivek from Dubai. Awesome. Nice to have you. Raiders from Orlando. Chelsea from Canada. Andy from Wisconsin. Michael from Jackson, New Jersey. Ron from Vancouver, Michael from, looks like Maryland, and Randy from Florida, Scott from Florida, not a lot of people from Florida here today, awesome. And we've got Vincent from Sacramento, Mark from Nova Scotia, okay. It's so funny, my dog is named Nova, and so I always call her Nova Scotia. My kids get mad. Okay, so we've got Tom from Cleveland, Ohio. Great to have you. Raul from Santo Dominico in Chile. Very nice to have you. Sander from Brooklyn, New York. Manish from Illinois. Excellent. Well, I know I haven't been able to introduce everyone, but I don't want to hold anyone up. I want to get us to our topic as quickly as possible. So again, today we are going to start the series on generative design. This is going to be the first in a series. And in fact, there it goes. This is our agenda for the next couple of months, in fact, until December the 22nd. I wanted to bring this up today just so that you know, for the next few weeks, we're going to be meeting every 2 weeks instead of every 4, so that we can get through this series. And again, this is just until December 22nd. And we do have more after this, so I just haven't put them on the schedule yet. But Jacob has a lot to say about generative design. I think you'll find it very, very valuable. So I hope to see you every 2 weeks to learn more about generative design. Just a quick note to our safe harbor statement. Because we are talking about a technology that may be brand new to some of you, may not be brand new to some of you, and we may possibly make some forward-looking statements. I don't want you to make any purchasing decisions based on those forward-looking statements because they are not promises that they will end up in the software, but we do like to keep you abreast of what we are working on and make sure that we're meeting your needs. So. All right, a few orders of business. The lines are muted. That's simply to reduce background noise. We do record the session, and a link to that recording is emailed out to everybody who registered. If you'd like to share that link with others, maybe your coworkers, family, friends, whoever, you are more than welcome to do that. After this session is over, we will continue the conversation in the forum. I have actually put that forum link in the chat panel as well. If you can't find the chat panel to be able to link to that quickly, post a question in the Q&A and I'll make sure I post that there as well. So we'll go ahead and skip that. So Jacob, I think we're ready to get started. Are you ready to go? I can't hear you for some reason.
Helps if I unmute myself first. Absolutely ready to go.
Okay, perfect. All right, let me go ahead and make you presenter. Okay, Jacob, the floor is yours.
All right. Oh, I need to change. I'm going to stop showing screen and start showing screen 2. Are you guys seeing the PowerPoint now?
Yes, we're good to go.
Awesome. Cool. So welcome everybody. This is we wanted to get the Dynamo product team, which is why Sol's here, and myself involved, to basically allow you guys to ask some questions. And that's really what this started with, and then partnered up with Michelle to basically bring this together with the architecture community meetups, because there is so much overlap, and this is a really hot topic for computational and generative design. Really, really big topic in terms of what's going on. So go ahead and introduce ourselves. I'll start. My name is Jacob Small. I am a designated support specialist focusing on generative design and BIM out of Autodesk's Boston office. That's a really long title, but that means I help customers that are in our EBAs, Enterprise Business Agreement, adopt Dynamo, Revit, generative design for Revit, and BIM 360 at a high level. With me today is Sol Amor. Sol, if you want to introduce yourself.
Hello, everyone. My name is Sol. Sorry you can't see my screen. I have technical difficulties today, so my apologies on that one. No face, but you can see it on screen right now. So I am originally from New Zealand, so hence the accent. If there's anything I say that doesn't make sense, please sing out in chat and I can clarify any of those potentially localized words. So I am the product manager for Dynamo. It's my responsibility to guide the product development moving forward. So to shape where Dynamo is going, to enhance where it's come from, to listen to all of you guys and girls and understand exactly what we can do to try and make Dynamo all that it really can be. And so just to kick off a little bit as a recap on what Dynamo is Dynamo is a visual programming language that allows you to sort of democratize the compute landscape. So what we mean by that is you basically get to plug a whole bunch of little things together to make a program, and that program can do really cool things. So if you're clicking your mouse button 10,000 times and not really engaging much of your brain power, you could use Dynamo to automate some of that process and get rid of some of that tedium in your work life. So really our mission in terms of what Dynamo is to provide a really simple, a coherent and capable programming tool for all of you. So a way for you to enter into creating your own solutions to your own problems in a way that really suits you and fits you. And Dynamo is looking to get easier and simpler and more powerful over time for this space.
Cool, great, thanks, Sol. So we also have a safe harbor statement. It's effectively what was produced before. Anything to add to that, Sol?
No, everything we say today, like nothing is really off limits when it comes to Dynamo, because Dynamo is fully open source. So if you really were curious, you could jump onto our GitHub repository, which is the place where all of the code that makes Dynamo lives. You can go and see absolutely everything that we're doing. So the only thing that we can't do is promise dates, because those are subject to change, but everything else that happens inside of the Dynamo ecosystem is all accessible and visible if you wish to go and have a look at it.
Yep, it's great having that extra degree of transparency. So, all right, so our plan for today, we wanted to start with kind of brief presentation on what object types are, followed by giving basically time over to question and answers so that we get whatever questions you guys have answered today. If we have time left over, if there's not a lot of questions, we'll go ahead and we've got some additional content to share as well. If we don't get to that, that's cool. We'll pick up where we left off in the next call. So generally speaking, anytime you're building any kind of compute process, it's really important to understand what data it is that you're working with. You can imagine basically at the simplest letter, computers basically a calculator, right? And this makes actually computers very unintelligent, and we'll phrase it that way. More or less, I could ask anybody on this call, what's 2 plus 2? Okay, well, that's very trivial, very easy. That's 4, right? 2 times A, okay, that's a little bit more abstract. Maybe it's double A. 2 times cantaloupe, okay, 2 cantaloupes, that makes sense, right? What about zebra divided by potato, or teal to the Londonderry power, stingray minus half past noon? These things don't make sense. And so when you're building up your graphs in Dynamo, when you're sort of designing these logic routines and these computational flows, it's really hard to or really important rather, that you keep in mind what it is that you're asking the computer. If you suddenly ask the computer something that doesn't make sense, it can't say, hey, that doesn't make sense. Can you clarify what you mean? Instead, it's just going to throw a warning or create an error, and that's really what this boils down to. So understanding what types of data it is that you have available to you and what you can do with those different data types is absolutely key in terms of building up different graphs and functions as you go. So you want to...
Yeah, I'll kick off here. So when we're talking about data types, these really are like the building blocks of Dynamo. So, Dynamo, if you're unfamiliar with Dynamo, what you see on your screen right now is a few nodes and wires, and these are also the building blocks of Dynamo, but the information that flows through these is based around this idea or this notion of data types. And so as Jacob mentioned, you have to explicitly tell the computer what you're trying to do for it to understand and execute that graph or that series of logic in the correct way. And so foundationally, we have a bunch of different data types, and the first set of those really is the basic data types. And so you'll notice on your screen, we have a little list, and that list contains 4 different aspects. So we have integers, doubles, strings, and booleans, or booleans, depending on where you come from in the world. The accent might change. I get called out for that one all the time. So on this note, so integers really, you can consider an integer simply to be a whole number. So, when you're starting out in primary school or the first year of school, and you're counting on your hand, 1, 2, 3, 4, 5, these are integers, these are whole numbers. One thing to take note of though, that in the Dynamo ecosystem, and most sort of coding or computer science languages, they do start at 0 as opposed to starting at 1. So bank that one for later, because this is the way that Dynamo also works. But a whole number, as you know, as I mentioned, is basically that, a whole number, and we call those integers. And short form of integer is int, int. So this is kind of like the alias or the nickname for integer. And you'll see this sort of around the Dynamo ecosystem. And when you go beyond Dynamo, you'll also see this in other places if you're looking to play with Python or C# or any other sort of computer science language. And so what you also have is a special character called infinity, and Dynamo also deals with infinity in some ways, typically by just throwing a warning, as Jacob said, and integers can both be positive and negative. So any number that's negative or positive upwards until infinity, but not inclusive of infinity, can be counted in an integer. There's one exception. We do have very, very large numbers where integers basically stop and get capped, but you, in theory and in practice, will almost never hit those. So then the second basic data type we have is called doubles. You might have also heard this to be called a floating value as well, but what you can think of in this one simply is that a double is a decimally placed number. So any number that is, say, 10.5 or 1.2 or 7.3, these are called doubles. Sorry, Jacob, can we jump back?
Sorry about that.
No worries. So the doubles basically, again, going up until infinity, but not including infinity, and any number that contains a decimal place. Pretty simple stuff. The next one, which is a little bit tricky, is a string. So a string is actually another word that means text. So inside of the Dynamo ecosystem, and again, any other language, a string is text. And the tricky thing about it is that you can have numbers that are encapsulated in a string. So you could have a string of just 0 or a string of 10. And that's actually text that is not a number. So if you come from, say, the Revit ecosystem and you're putting in some numbers or you're putting in a parameter into a field, that field will have to be specified to be either text or number based. And in the text based one, you can also put numbers. And that's the same kind of concept we have here inside of Dynamo. So one thing to be aware of is that we have this really cool node on the right hand side called object.type. And this node tells you what kind of data type is coming out of that node. So in the case of the string from object node, where we're changing our numbers into a string, that is telling you that it is a system.string, which basically just means this is text. And then the final one that we have is called Boolean or Boolean. And in this case, it simply means true or false. And again, if we use a Revit analogy, anytime you have one of those radio buttons that has got a tick or an untick, that is also a Boolean. When you're talking about computer language of ones and zeros, that's also, again, a Boolean. It's true and false, yes and no. These kind of concepts are all synonymous with themselves, and it's simply telling the computer whether or not something has truth or falseness.
Cool. Great info there, Sol, thanks. There is a question in the chat that's perhaps relevant here, so I'm gonna go ahead and field that one live now. How big is that theoretical number cap? 20-mile limit in Revit was also one of those ones that we were never supposed to actually hit. Sol, I know you know more about this with the changes to Dynamo in terms of what that number is, but I know it's a very, very scary large number to the point where you're sort of counting the number of digits in there. Do you recall what that is? I think
it's around the vicinity of like plus minus 30 different values. So we're talking seriously large numbers. You may hit those if you're trying to build disparate buildings between, say, Montreal and San Francisco, but you're probably not going to hit that in practice when you're working inside of Dynamo or you're working inside of Revit. The 20-mile radius one is a slight difference. Dynamo is unitless as well, so just to put that out there, that depending on the units that you're using inside of Revit, Dynamo will pick up on those and just run with it. So if you're working with millimeters, you might run into this slightly more than if you're working with the imperial system.
Yeah, it's a great point. And one thing that I'll point out as well, you mentioned before sort of the string to object and sort of understanding or the difference between strings and the fact that strings can contain numbers. A really common example of that helps to understand is when you're trying to set, let's say, a room number. Now, this is a little bit backwards because we call it a number, but in fact, we can have a room number of like 101A or 101B that is a sub number to room 101, right? And so as a result of that, the value for room numbers are actually strings. So if you are writing one of those sort of my first graph, a common one is to read Excel data and write it into room numbers. Understanding that, you need to convert that content to a string is a really great place to start. All right, on to the next set of data. So after we've got that basic data set up, we can start to build stuff that's a little bit more complex. That first complex piece, there's really sort of 4 basic types, and there's more than this, there's subtypes to this, but if you've got a good understanding of these 4, it really will help you sort of understand where stuff goes from here. So the first type of complex data that I wanted to go over today is colors. These are just like you may have learned in Adobe Photoshop or Microsoft Paint or even PowerPoint, right? It's 4 numbers that define a transparency value, a red, a green, and a blue value. These are integer values that range from 0 to 255, where 0 is going to be fully opaque, 255 is going to be entirely invisible for your alpha, and 0 is going to be completely black on that scale of the color spectrum, and 255 is going to be crank up the brightness all the way to, as bright as possible. If you do have consistent values for your RG and B values, you will see shades of gray, right? So 255 for RG and B will be totally white, 0 for RG and B will be totally black, and all those shades in between. So you can make pretty much every color that's out there. As you can see, 255 values, you're basically getting your typical 255 point 256 color point values, which is pretty good to see. The next data type that I wanted to go over is paths. Paths are basically where files or directories are located on your system. Now, one thing that's really important to understand is these will vary from user to user. So if you path something to your C drive, so if I went to C users Jacob my super fun project, and I send that graph that refers to that location out, unless you have the same path to the same file on every system, it's not necessarily going to scale out. So that's one thing that you do want to keep in mind. Maybe use something that's on the cloud or host something up on BIM 360, or maybe look at serializing that data into something that can be stored in the Dynamo graph itself rather than relying on those external files. External files and directories, though, are extremely useful. And then the next piece that I wanted to sort of cover here. So files are basically structured sets of data stored in a given format. Some of these formats Dynamo can read, such as CSVs, TXTs, image files, so on and so forth. Some of them Dynamo can't read natively, such as Revit files. Dynamo's not going to be able to read any Revit file. You have to have Revit open that file in the background and send you the data that you're after. In other cases, you can rely on extra packages to read that content. So if you want to interact with an Autocad document while in Dynamo for Revit, we could use the link DWG package to access that content and work with that DWG file, which is pretty cool. In all cases, your files do have to be generated by something else. So that's why you can see here in this graph, we started with this file path node and then expanded it out to a file from path so that we now have that file info so that we can get to the structured content, the content that's stored in that given format. Directories are basically where collections of files and other directories live. With that content, we can basically open up multiple sets of files or find what other files might live in there or what other directories live in a given location to keep that content active in there for you. And then last but certainly not least, specifically in the realm of Dynamo, is geometry. Geometry is exactly what it sounds like. This could be as simple as a point or as complex as a mesh like the Stanford Bunny or a model of one of the Avengers or something like that. This is a huge topic within Dynamo. Obviously, so much of what we do as building designers is sort of centered around creating shapes, and that's exactly what geometry is. Different geometry types will have different ways that they can be manipulated and created based on what it is that you're after. So if you want to make a point, it's as simple as providing perhaps 3 numbers or a parameter value within another shape. So all types of cool stuff that we can do there. And you can see different ways for making those with creating a cuboid here by links and then feeding that right into a object type node to sort of understand what it is. And that autodesk.designscript.geometry is telling us that this is a geometry element. Specifically, we are looking at a cuboid. Anything to add to this stuff, Sol?
Nope, that was pretty well covered, Jacob.
All right, thanks.
Awesome. So I'm going to talk a little bit about some special data types. So these are ones that get a little bit funkier in some ways. And so you're going to run into some of these or all of these at some point in your Dynamo journey. And so these special data types are functions, a null or a nothing or a no object, which is an interesting case that you will definitely run into pretty much in the first 2 or 3 graphs that you try and build. Then host specific things such as Revit elements or Civil 3D objects or format geometry or any host data that you can insert here. And then also things called custom objects. So to go through these a little bit, functions inside of Dynamo, every single node is in some ways a function inside of Dynamo. And so when you have a node that has all of these input ports, so the things on the left-hand side that are unfulfilled, which basically means you don't have all of the data that it needs to work, you're going to return what's called a function. And so that basically means like, hey, I'm Dynamo, I'm waiting. You haven't kind of given me all the information I need. Please go and plug this stuff in. And so typically when you see the output of a node saying function, there's something you need to do. Now there's some special cases here that we're probably not going to get into today, which is called function parsing, which means you specifically build a graph that uses those function objects. And that's kind of a little bit advanced, and we're going to skip that. So typically, just remember that if you see the word function, you probably have an input port that needs some information going into it. So in this case, on the screen, we have a number and a divide node or a divide function. And what we're trying to do is divide nothing by 1, which is just simply going to return, in this case, a protocol DSASM stack value, which doesn't really mean much. What it really means is that there's an unfulfilled node before this. In this case, we need to actually put a number in to divide it. So if we wanted to put in, say, 10 and divide it by 1, we'd get a result. Or if we wanted to put in 5 and divide it by 2, we'd get a result. But in this case, we're currently not. So the next kind of data type that we're going to jump into is a thing called a null or a nothing. So if you try to divide a whole bunch of text, in this case, some sort of quick brown fox jumping over drafts or something, divided by a number, it is not going to work, and it's going to give you a null. So what you're going to see in the object type node is this word null, and null simply means nothing. It just means like, hey, I'm a computer, and you've tried to make me compute something that just really doesn't make sense. So I'm just going to say, can't do it, sorry, and my return for that is null. You're going to run into these all the time. So a null object is something when the computer can't understand what is happening. So it's just going to say, I'm just going to pass nothing downstream. There's a few other sort of special data types like empty lists and sort of empty strings, so when information is missing, but null is the most common of these. And so we deal with nulls inside of Dynamo explicitly at the start of the graph to try and get rid of this kind of complexity or problem space before we move downstream. So just note to self that you will see your node turn yellow, and this is a warning state, and you'll get a little bubble at the top of it, which is going to give you some information on what that warning is and potentially how to solve it. We've got some information in Dynamo now, some sort of verbose help that allows you to jump in and understand a little bit more about what's going wrong for the 30 most common error messages. But what you'll see in the preview bubble drop down at the bottom of that node is simply null. So when you run into null, there's certain ways you can go about dealing with that. What we have after that in terms of data types is specific host stuff. So if you're familiar with Revit, in this case, it's say Revit elements. So maybe a wall or a door or a window. And so if you're using Dynamo in the context of Revit, you can then jump into the Revit model and pull things from it. In this case, using the select model element node, pull in a wall, and that object type is going to come from the Revit API. So the API is the application programming interface inside of Revit. It's kind of hardcore stuff, and like you'll get into it when your Dynamo journey goes down a few rabbit holes and you get curious about things. But at the outset, suffice it to say that you're basically doing the same thing that the buttons inside of Revit are doing when you select this. So if we select a wall, we can then get the properties of that wall. We can get its height and what levels it's attached to. We can get its volume and its area and so on. And so that's true with every other host that Dynamo sits inside. So Dynamo lives not just inside of Revit, but you can also use Dynamo inside of Formas and Civil 3D and Advanced Steel and Alias and Robot Structural Analysis. And so all of those different host applications will also have their own objects that you can access and do things to. And then the final kind of object is this thing called like a custom object. And so the custom object is when somebody wants to make a package themselves and they just want to build it in their own kind of unique custom way. So what you'll see on screen is a speller.speller, which is going to come through as an Archilab spellcheck.speller. So this is a special object that is basically wrapping up a spell checker inside of a single node, but you as the user don't really need to know that. You just need to plug that spell checker into another node that queries the uses that spell checker to then query your own textual information or string information. And so this is when a custom node author hasn't got the tools that they need out of the box to kind of do the complex stuff that they want to do. And they want to do all this complex stuff so they can then give it back to the community on the package manager so that you can use it and do really cool things like, you know, check the spelling of every single piece of text inside of an entire Revit document, for example, or an entire deliverable set of drawings. Anything you want to add to here, Jacob?
No, one thing you do want to keep a close eye out on those custom object types. They tend to sneak up on you because the names are often pretty close to what you might expect when it says, you know, I'm looking for a document. Well, there's multiple nodes that produce different types of document, be it, let's say, an Orchid document or a Revit document or, you know, a Word document. So definitely take a moment if you're not sure about what stuff's supposed to be. Look for other nodes within that package, within that section of your library, and you can usually find the node that it is that you're looking for. Other than that, I think this was really well covered. Thanks a lot, Sol.
Cool, no worries.
All right, so we're at the point where we wanted to start sort of taking some questions from you guys, make sure that we're covering sort of the content that you have, not just sort of this basic stuff, but we have anything that's a bit more advanced. We're here for you to make sure that we get your questions answered. So anything from anybody on the audience? It looks like most of the stuff in the QA is picked up at the moment.
Yes, we do have one raising their hand though, and so I would love to open up Francisco. Whoops, that just disappeared. Okay, maybe he changed his mind. If you do have questions and you are brave enough to ask them live, definitely raise your hand in that attendee panel, and I will unmute your line and open it up to the phone lines. And it looks like we did have a couple of questions come in. Sander is asking, how do you write your own nodes?
Ooh, this is a dangerous one for sure. There's a few different ways you can do that. My personal preference, so I'm not trained as a coder, I'm trained to design buildings. Sol can speak a little bit more to the higher end stuff, but when you're first getting started, the easiest way to make your own nodes is to use the custom node function in Dynamo. And there's an amazing tool where basically you build up the portion of your graph that you want to wrap into a custom node, select those nodes, and you can basically just right click and say create custom node. Then you're going to give it a name, tell it where you want it to live in your library, and push that content through. And once that's done, you can continue to develop that out, make some changes in the custom node interface. And these are going to build DYFs. There's no sort of external programming environment or external sort of need to understand any kind of textual coding or additional dependencies. You're working just within the limits of Dynamo still. And it can be extremely powerful. With what you can do with those is great. There's a much higher bar than a lot of people realize, but there are some drawbacks. To get a little bit more advanced than that, Sol, do you think you could speak a little bit to creating zero-touch nodes?
Yeah, so to maybe backtrack slightly before that, so Dynamo has many different ways that enables you to create custom content. So we kind of have this like growth path or growth pattern where if you're jumping to Dynamo for the first time and this is your first foray into sort of visual programming and understanding that kind of world, then you'll start using nodes and building your own graph, which is great. And then like Jacob just said, if you want to start to leverage that power in sort of slightly smarter ways, you can encapsulate some of that content into a custom node. So we have a framework that allows you to do that, which is quite simple once you wrap your head around a couple of sort of niche things, which is really cool. So maybe if you're using like 10 to 20 different nodes in the same way every single time, that's a really good candidate to sort of promote to a custom node. But you will run into limitations at some point with that because custom nodes will only allow you to use any out of the box or any other package created nodes from the community. And maybe you want to just build your own that does some really cool, really high powered stuff. So we have a couple of different avenues for that. So inside of the custom node environment, you can also use Python if you want to. So we have a Python node inside of Dynamo that has access to both the Python 2 environment using a specific flavor called IronPython and the Python 3 environment using sort of a more native Python interpreter. There's some technical jargon there, but basically you have access to Python, which is great. And that enables you to sort of talk to the Revit API, for example, to do things that may not be expressed out of the box in nodes, potentially bring in external content. So we call them libraries that do really cool things. So in the data science world, maybe you want to start doing some machine learning things. This will enable you to do that yourself. And then we have another framework called like Zero Touch, or these like C# nodes. We have a bunch of different names for them, but what that means is you're kind of building nodes the same way that we do on the team, which is using a particular language called C#. And we have a framework as well, which can express nodes within that. So you simply load up the template of this different framework and just fill in the blanks, doing whatever it is that you want to do. And so this is really powerful. All of the flavors bring a lot more power than sort of building a graph out of the box may do so for you. You can have smaller graphs with less nodes. You can have graphs that are way more highly powered, doing really cool things. And all of these different flavors, there are some trade-offs made with them. That's kind of beyond the topic of the conversation today, but suffice it to say that any one of those paths is powerful and any one of those paths is worth traversing. And once you learn one of them, you'll start, working your way through that kind of landscape, and then you'll hit a limit of what you can achieve at that, you move on to the next one. And the steps in the path or the steps in the journey really do lay really strong foundations for any future growth. And we do see inside of the sort of Dynamo community that people start out being designers and start, maybe want to try their hand in sort of the manager space or the computational design space, and they will progress very quickly using Dynamo as a vehicle to educate them in some of these sort of like underlying foundational tenets of building software and building applications. And you kind of learn a bit of that by default. Like Jacob touched upon it really briefly, but just even understanding the data types and the way that Dynamo expresses those and the information that it gives you back on the nodes kind of starts teaching you some of these foundational things by default. So from my perspective, like I would strongly advocate for learning any one of these things and just whatever one sort of like tickles your fancy most. It's kind of like a flavor choice at the end of the day. Some people like vanilla and some people like chocolate.
Yep. And I think, go ahead.
No, go ahead, Jacob.
I was going to say, I think Sol's description there actually answered Noah's question really well about if you know enough about Dynamo to be dangerous, where do you recommend going to get into even more trouble? And that's definitely kind of a good direction to go. Start looking at authoring your own packages or even, view extensions and content like that to sort of up that level of danger and seeing what else we can really start to expose to make the process easier for everybody.
Yeah, so to touch base very briefly, the one thing I didn't talk about was view extensions, like Jacob said. So just in the same way that like Revit has add-ons and people can make those and you can download them from the App Store and do really cool things, Revit has the same kind of thing. So at the sort of first rung of that ladder, it's custom nodes, but the second rung of that ladder is a thing called extensions, which is basically you're actually changing the program itself. You're changing Dynamo to a way that you see fit. So if you've used Dynamo before, you'll see some of these expressing themselves through, say, John Pearson's monocle extension, or the data shapes extension, or the Dynamaps extension. So there's different ways that sort of developers or people from the community who started out as designers have decided like, hey, this part of the application is great, but I wish it could work better. So maybe I'll go and make my own way to do it. And I've gone and done that and then shared that back to the community, which is really cool. And then one other thing, Noah, to your question in particular is we have so much different resources out there. So depending on your level of danger, at whatever your level is, I would strongly advise that we have a Dynamo Primer, which is great. Go through and learn and understand the concepts of Dynamo. We also have a Developer Primer, which is probably what you're more targeting right now. And so that Developer Primer is a place that you can definitely cause some damage, but also create some really cool things. So it's a place I would advocate. It's accessible on the website as well. So if you just go into the Dynamo website and the drop down at the top, there is a developer link, and you should be able to find your way towards it.
Great. And we have Francisco Mazzotti, I hope I pronounced your name right, is raising his hand. So I am going to open up your line, Francisco. Are you able to speak with us?
Yes, can you hear me?
Yes.
Thank you. And I have a dilemma that I would like you to help me to solve. I'm an architect and I work for a medium-sized company. We do a high-rise commercial project. And we use Revit for our documentation, and sometimes even for the design process. But a lot of the young talent that is coming to our office are really, really fluent in Grasshopper, Rhino, and all this other software. And so the dilemma is, ideally, we would like to consolidate all the design process in one platform. Obviously, if we could keep everything in Revit, it would be beneficial. But somehow, the universities or the schools are teaching the other software, not Dynamo. So my question to you is, can you, first of all, is Dynamo able to do the same thing that Grasshopper does? The second one would be, what are the advantages of one versus the other? And the third one would be how you would convince me or someone else to learn Dynamo over Grasshopper, as Grasshopper and Rhino have a huge platform that is already established, and seems that you guys are a little bit behind. So how do you fill the gap? That's it. Thank you.
I guess that's a question targeted towards me.
I'm not an expert on either of these platforms. I'm just trying to understand the benefits of both.
Right. Okay, cool. So like fundamentally, Grasshopper and Dynamo are both part of the same kind of like foundation, which is visual programming, which I kind of touched upon earlier. So there's other visual programming environments out there as well. You might be familiar with generative components in the Bentley ecosystem, which was sort of even predated Grasshopper. There's a bunch of different ways or expressions, all of these are, to try and democratize the ability for designers and people who are visually orientated to use technology in a way that they can build their own programs to solve their own problems. So like Grasshopper is older than Dynamo, so it has sort of 5 or 6 years ahead of Dynamo in terms of like use case. We're playing catch up to a certain degree, but we're also very different. So there's like pros and cons on both sides of the fence. So Grasshopper lives inside of Rhino, whereas Dynamo lives inside of many different places. So, if you want to use and learn Dynamo, you can learn it inside of Revit, for example, but then you also by default understand Dynamo in Format, Alias, Civil 3D, Advanced, Steel, Robot Structural Analysis, all these other places, because Dynamo foundationally is exactly the same thing, and all you'd have to do is understand the specifics of that host. So you need to understand Civil 3D objects versus Revit elements versus Format geometry. So there's one really strong benefit in what we call like the ecosystem. So Dynamo expresses itself in many different places, and by learning one, you can start connecting all of these different sort of ecosystem players together in better, stronger, more powerful ways. What we also have is Dynamo is very good at dealing with data. So if we're talking about like Revit as an example, Dynamo is very good at manipulating and sort of like fixing or improving the way that you can use Revit to a more higher powered way. So for example, if you want to generate sheets from an Excel workbook, like I worked so my background's also in architecture, sorry, I didn't touch upon this earlier. If you worked in the UK and we generate like sheets from a particular Excel sheet, and there's like a really strongly managed process of any kind of change and change control, you can do that very quickly with Dynamo and manage that change control very well and very easily. So Dynamo has historically been used for sort of like two different camps. One of those is geometry, so like computational design, and the other one is data management. So the data management sort of falls into the BIM manager category. Computational design falls into more the designer category. But both of them are very powerful, and Grasshopper has a very strong sort of like history with computational design, doing really cool things in the design space. Dynamo has a very big strength in the data side of things. So really automating away the tedium in your daily life. If you're clicking your mouse a lot and you're not engaging your brain, this is a really good candidate to generate a graph or a routine that will sort of like automate that process and save you some time. And Dynamo's geometry capability is different as well to Grasshopper. So Grasshopper is a surface modeler, whereas Dynamo uses more solid modeling. So there's pros and cons in that. Dynamo is currently a little bit slower, but not slow. And we're getting faster sort of day on day, release on release, and getting really good. But it also allows you to do some really powerful solid things that Grasshopper doesn't allow you to do. So you can join solids together that are not touching. You can do some really interesting and powerful Boolean operations where you're slicing and dicing and taking things away or adding other things to the geometry. So at the end of the day, really, they're different flavors. We are looking to make Dynamo all that it can be. We love the fact that Grasshopper exists because we have sort of somebody to not just benchmark ourselves against, but also to understand the ecosystem and the play of where we sit and we fit, and we feel like we bring a lot of value to our customers. And that really sits within the really extremely powerful solid modeling operations. It sits within the ecosystem play, and it sits within a very strong penchant and like capacity to deal with data in very powerful ways too.
Yeah. One thing that I will add, my personal preference is as long as you're automating, you're doing good. You don't want to sit through and say, you know, whether you're placing 1 million curtain panels in modeling application 1 or modeling application 2. If you're having to go through and click 4 times 1 million, there's a problem, right? So as soon as you start to think less about, okay, I have to click here and click here. As soon as you start to think about, I need to have something, put something here, and you break that mindset, suddenly things start to go pretty quickly. The great thing about both of these applications, because they're both visual programming environments, it's fairly simple to bounce back and forth. You basically learn data trees in one versus list levels in the other, and once you make sense of that, content is content, right? The idea of doing that automation is there. Personally, I did gravitate more towards the Dynamo side when I was getting started, solely because the amount of stuff that it can interact with. So I can right now write a graph that will optimize the layout for the site plan in Civil 3D, in Format, in Revit, in whatever it may say. And it's basically the same graph in all 3 locations. So there's a little bit more reusability there, which I found very nice.
Great. Thank you, Francisco, for being brave enough to ask that live.
Thank you.
Great. Let's go to Aaron W. Aaron, I'm going to unmute your line. Are you able to speak with us?
If you can hear me.
Yes.
Excellent. All right. So curiosity question here, and let's go back to the basics, if we will. So I'm wondering if there is a more formal set of steps or a formal way to learn the steps in how to put together a script. Let me give you an example. Let's say we have half a dozen detail views that we want to put onto a detail sheet. These detail views have a bunch of numbers in the front. They have the name of the detail in the back. All of the names are preceded with a symbol, let's say a star. I know that I want to go from step A, I want to grab that string, and at the end, step Z, I want to get that string put into the title of the drafting view, right? Mm-hmm. I've recently learned that there are 5 other steps involved in getting that string and separating it to be able to put it into play. Now, A, I have to figure out what steps those are, and then B, I have to figure out the proper name for those steps so that I can search for the elements in Dynamo. Is there a way to find these, or is this just a live and learn, fight and forget kind of a thing?
So there's a few different pieces there. The first is, how do you plan your graph, right? And this is actually something, so part of my role in helping customers adapt the applications, I spend a good amount of time basically showing users more or less how to plan their graphs. And it's something I do probably about 15 minutes straight session on just that. And I think we're going to cover that. I don't know if it's currently on the list of topics, but the intent is to eventually get there with you guys. And my advice is to actually step away from the keyboard. We don't use the keyboard. We don't use the mouse to plan this stuff out. If you open up Dynamo as step one to writing a Dynamo graph and you're not it's something you haven't done before, you don't know exactly what you have to do, you're probably going to struggle. Instead, step away, go to a whiteboard or a notepad or whatever else, and literally write down, okay, if I was to do this by hand, the first thing I would do is this. The second thing I would do is this. The third thing I would do is this. And, even just draw lines and say, connect from object one, I take that data over here, and I'm going to use that same thing again back over this way, and it will look like absolute gibberish, but it will give you a map that you can follow so that you don't get lost halfway through when you're like, I don't know how to perform this one step, right? Because the worst thing that can happen is you start automating the process, you get 75% of the way there, you can't find that last piece, and then you're like, okay, I could have done this by hand now, time to move on. And you can't pick back up because you don't have that map. So always build that map first. Once you have that, sort of figuring out which piece, a lot of it has to do with that object type, right? Another portion of it has to do with a really good understanding of what happens under the hood in Revit. The object type, if we go back, actually, I'm in control of PowerPoint, and I think I might still be sharing. So this node all the way over here on the right, that's this object type node, tells you exactly what it is that you're looking for. And if you hover over any one of the input ports, it will tell you what that node is expecting for a data type. So it'll let you know what you need to find. And now you can say, what do I have now? And start to look through, okay, it's expecting a string. I have an integer. I need to figure out how to go from string to, or from integer to a string. How do I go from an object to a string? And you can start to find that content in your library a little bit easier. In the end, it does require some degree of understanding of, familiarity with it, but that will come in time with use. Just like the first time you did the aspect in Revit, you had to understand, oh, the view title on sheet is different from the detail name. So that same piece sort of applies on both directions. Anything to add, Sol?
Nope, that pretty much covers it. Thanks, Jacob.
All right, easy enough.
Thanks, Darren, for being willing to ask that live. So let's go back over to the Q&A panel and let's capture any that we haven't answered. Let's see. Okay, so Doug is asking, can you go over how to open up a Revit file on Autocad again?
I may have spoken backwards. You can do the opposite. You can read a DWG from inside Revit, but because the Revit API, it's basically a one-way street. The only way to get inside a Revit file is from inside Revit. What you can do is you can open Dynamo for Revit and then read your DWG data, but you can't open Dynamo for Civil 3D and read your Revit data. There is an application, if you're looking to join DWGs and RVTs, there's an application out called Civil Connector. If you Google that, you can find that online, just Civil Connector GitHub. There's all sorts of great information about that, which will allow you to bidirectionally move from Revit to Civil 3D. There isn't one for base AutoCAD though. It's sort of the two higher level pieces because it does need that extra API access.
Okay, great. And Nick is asking the question, do you think that the new interfaces in the generative design viewer will be able to complete all of the same functionality of data shapes UI plugin?
I could probably answer this one, Nick. So they're fundamentally, like they're similar in some ways, but they're quite fundamentally different in others. So the generative player is specific for it uses Dynamo as a backend, first of all, and it uses Dynamo and Dynamo graphs to basically explore within like a design space where you set like the bounds of that space, like the minimums and maximums within which your design can sort of birth itself, if you will. And it uses an interface to enable you to explore sort of optimization routines, randomization routines, or cross-product routines that allow you to sort of explore this design space. The Dynamo Player is more akin to what you're talking about with the data shapes UI, and they do a more similar thing, which is basically building your own custom UI for your own custom program that a user can interact with and do things. So as it stands right now, the data shapes package, which is an extendable package, for those of you who don't know, to Dynamo, it allows you to build all these really cool things, has more functionality than Dynamo Player does out of the box, which is really cool and enables you to do really awesome things. In the future, we are looking to improve the Dynamo Player, but as it stands right now, I would say lean on the data shapes package because it is really powerful and does really cool things. But to fully answer your question, the generative design viewer is fundamentally different to what the data shapes package enables. They're slightly different things.
Okay, great. And Nick is also asking another question. Can you talk about Rhino inside integration with Revit and Dynamo?
Right. So I have. Oh, you go ahead, Jacob.
I will defer to you as the product manager.
Right, the buck has been thrown to me. Cool. So Rhino inside is basically taking Rhino and putting it inside of Revit, which is fundamentally what we've actually done with Dynamo as well. So Dynamo is inside Revit too. So Dynamo is its own application. It's expressed as kind of like a feature of Revit, but like I said earlier, it's also expressed in these other places too, in other applications, which is at the outset the same kind of thing, right? So you're taking one application, you're putting it inside another application. The integration with Rhino inside specifically, you'd have to ask the Rhino camp and ask McNeil what their plans are and what they're trying to do, and have a look on their side of the fence for some specificity. But from our side, like, we welcome the ability for all of you guys really to do, and girls, to do exactly what you want to do and try and solve all of your problems at the end of the day. Like Jacob said, like, you know, there's many different ways to achieve a result, and whatever one works best for you, please go and do it. So we welcome Rhino inside from our side. It will cause us to be better too. I mean, competition is a good thing. It'll mean that Dynamo will get better by default as well. And then they will also sort of explore and run into some of the limitations that we have explored and ran into with Dynamo being inside Revit in the first place as well. So beyond that, Nick, you probably have to go to the Rhino side of the camp to get more of a grasp on really what they're trying to achieve and how they're going about achieving that.
Well said. There is one piece in here that I think I'll touch on real quick. I'm seeing it from Ryan Johnson, where the question is, we had this node where we're basically dividing nothing by 1 and we're returning a function. Basically, a function is a thing that we can perform on other bits of data. So in the old version of Dynamo, if we went back to the 0-6 days, right? Back when the nodes were yellow, they were all yellow, believe it or not, at one point. Basically what that allowed us to do is say, do this series of steps on whatever data I eventually give you. And we could use a list.map or a function.apply node to basically get the same functionality that we're able to get now with list lacing and levels to keep that content moving forward. We made it simpler to leverage list lacing and levels. There are still some reasons where you might want to use a function statement as opposed to sort of dealing with the list lacing and levels, but it's fairly rare, and you can actually become a very skilled user without using that particular content these days.
Can I touch upon one other question as well? And so there's a question from Rabindra asking, Grasshopper is more visible and showing data flow more graphically. Dynamo is somehow limited. Is there any work to go into understanding how data flows through Dynamo? So yes, currently we are working through a visual refresh of Dynamo. So what you see in the screen today is fundamentally still going to be there, but the way that we express information, the way that we express data, and the way that we express data flow is going to be improved with the specific regards of trying to make it easier for new users and beginners of Dynamo. So we're looking to lower the barrier to entry inside of Dynamo and just make it like really powerful and easy to use, and have all of the information that you need at your fingertips when you need it on the front end, while still being exactly as powerful, if not more powerful, in the back end, and doing all of the cool things that you can achieve today. So we're really trying to democratize Dynamo even more and move into a space where it's less niche and it's more sort of open and expandable and usable and abusable in the good way for you on the cold face of the industry trying to solve all your problems that might take too much time currently.
Right, there's a question, and I apologize if I say this wrong, Tadia, is asking, it would be great to see Dynamo able to run across many Revit models at once. Are there plans for Dynamo scripts to work outside of Revit so we can process a lot of Revit models instead of one by one?
Short answer, yes, there's plans. It's not in the short term, unfortunately, but so currently Revit is what we call like single process or in process, which means Dynamo works within a single thread. And so if you're using Dynamo in Revit, you'll notice that it kind of locks up Revit because it's in the same kind of environment. And in the future, we're looking at two different angles. And one of those angles is really about improving the ability for Dynamo to talk to the broader ecosystem. And so this is around connections through Forge and connections through design automation. So we're not entirely sure exactly how that's going to express itself, but we really are trying to get to a future state, and hopefully in the not too distant future, where you can generate a Dynamo graph that does something such as like a QA routine that it just runs and passes the Dynamo graph and then spits out all that information to a Power BI or an Excel workbook or something somewhere. And we want you to be able to run that across many different Revit documents. So the intention is very much there. We're having very strong conversations about it right now. The work is not yet started because we're trying to figure out the best way to try and achieve this that would actually work and solve the kind of problems you're looking for.
Great. We only have 4 minutes left, so I'm going to ask you a really random question, not totally random, but what is the coolest use of Dynamo that you've ever seen? And this is coming from Aaron.
Coolest use of Dynamo. Depends on the context. Like, okay, so if you're taking like a data cool workflow, there was a really cool workflow for a building in Paris in France where Hovard Vachard placed 26,500 different panels on a building using Dynamo, basically all at the same time. Now, it did take like, an hour or so to run and chug, but that was 26,500 that he didn't have to place manually, and those also understood the conditions of when the building wrapped and changed, and there was this concavity to the building that meant that the what we call edge conditions of those panels, when the panel traversed into a different topography, they had to understand those. And so not only did it place those 26,500 elements correctly, it placed them understanding those conditions or the localized conditions of the geometry, and it also managed to do a really cool randomized color pattern on the facade as well. So I thought that was super cool, and that was using Dynamo like 4 years ago. I think that it still stands the test of time in terms of like a really awesome application of Dynamo when it comes to like more of a data-centric workflow. So yes, you're using geometry, but you're using the data of the model to understand how to place that geometry in a really smart and cohesive way.
Very true. I'll answer the same. My favorite use cases for Dynamo, the ones that literally I'm wowed by it every time, is when I see something that I did not expect. So whether it's something, like generating that geometry, yeah, I've come to expect that now, but something like automating your CA process, right? So there's offices out there that have done this where they've said, okay, I have to go out on site, I have to generate a field report of everything that I saw. What were the issues outstanding from last time? What's the weather conditions on site? All this other stuff. To basically be able to automate that, put that on a Word document on your phone, and then just speak your notes into Siri, get back, and then upload it for spell check and send it out to take the process of generating that field report that takes some offices weeks to put all the way together because everything else sort of piles up. It's getting done in a matter of minutes now. So something as simple as that can be really, really powerful, and I always enjoy getting to see. We did want to. Oh, go ahead.
Oh, so one more really quick example. So you can also do things like talk to Google Translate. So you can just basically change the entire language of a document set. So for example, say you're living in Canada and you need to do the document set in both French and English. You would be able to do that just using Dynamo very, very quickly.
Yeah, that's another great example too. I did want to share some quick resources. This will be in the PDF that we'll distribute at the end, but information about basic Dynamo news is all pretty well organized up there. How to get started with Dynamo, definitely start with the Dynamo Primer. I say this all the time, don't skip any exercises. If it seems like, if you're a plumbing engineer primarily, like I'm never gonna have to place solar panels on a roof. It's not about placing solar panels on a roof. It's about learning list lacing and list levels so that you understand how to work with this stuff at scale. So definitely take the time to go through all those different pieces. And then also to answer one of the other questions in the chat, is there an encyclopedia of sorts? All the out-of-the-box nodes are available, well, pretty much all of the out-of-the-box nodes have an entry on the Dynamo Dictionary at dictionary.dynamobim.com. You can go there and find specific example, not just what the node does, but also how to use the node in a real graph that you can rebuild on your own and play around with, which is pretty cool.
Very cool. Well, we are at time. Thank you so much, gentlemen, for your time today. I really appreciate the great presentation and answering so many of the questions. For those questions that we did not get to, let's continue the conversation in the forum that I included in the link. You'll also get a link to that in the email. You'll get a link to Jacob's slides so that you'll have those learning resources after the fact. And for next time, we are meeting on October 14th, where you will learn how to find the right node in Dynamo. So all of you that had those node questions, make sure you meet us next time on October 14th. Otherwise, thank you very much, and I appreciate everyone's time today, and I hope to see you next time.
Thank you.
Cool. Thank you.
Take care.